So today we are going to look at integration by parts. And integration by parts, this is the formula, the general formula that you are going to use a lot. So as we go on, you will get to know how we use this formula. But integration by parts, this is the general formula you are going to use. And when we are integrating by parts, we are going to use this mnemonic, Liate here. That is Liate. So when we do examples, you'll get to know how to apply this Liate. Now, to start with example 1, what is the integral of x exponential x dx? Now, before we start this integral, let me explain how Liate works. In Liate, L stands for logarithmic function, I stands for inverse trigonometric function, here I stands for trigonometric inverse function, A stands for algebraic function, T stands for trigonometric function, and E stands for exponential functions. Now this Liate, they are arranged in order, starting with L, the highest priority, and E with the last priority. Now, whenever you are given a function to integrate, you will look at the function, and Liate will help you to choose your u. Now, let us do this example so that you will understand how Liate works. Now, when you are given an integral like this, the first step is to choose your u and your dv. So, let your u be and your dv be. Now, we apply Liate. In this integral, we have x, an algebraic function, and we have ex, an exponential function. Now, which one will be our u and which one will be our dv, right? So our u, we look at Liate. L is the logarithmic function. We don't have a logarithmic function in this integral. The next one, an inverse trigonometric function here. Do we have? No, we don't have. The third one, we have an algebraic function. Yes, there's an algebraic function here. So our u will be x, the algebraic function, because it has a higher priority than an exponential function here, which is the last priority. After choosing your u, the remaining part becomes your dx. I mean your dv. Now, the next step after choosing your u and your dv is to find the derivative here and to integrate this one here. So let's do that. So what is the derivative of this? That will be du dx is equals to 1. The derivative of x is 1. So the next thing is to make du the subject. When we were doing integration by u substitution, it was dx that we make the subject. But integration by parts, it is du you make the subject. So let us make du the subject. You take dx the other side. So we have du is equals to dx. Now, the next step here is to find the integral of this part. So that is the integral of dv. You find the integral on both sides, dx. So the integral, remember this is a derivative. An integral and a derivative will cancel out. We remain with v. Let me write this properly. We remain with v. So what is the integral of exponential x? The integral of exponential x is still exponential x. Now, When you're done finding the integral, here we have our v and we have our du. We can erase this part. Now we apply the formula. This is our formula, right? So let me just rewrite it here. The integral of uv, that is u dv. The integral of u dv is equals to uv minus the integral of v du, right? So that is the integral of, what's our u? Our u was x. What is our dv? Our dv was exponential dx, right? Is equals to, let me just erase this one so that we can find some space. Is equals to u. What is our u? Our u was x. What is our v? This is our v, exponential x, minus the integral of v here, exponential x, du. This is our du here, which is dx. Now we have substituted everything in our general formula. Now here you realize, when you look at this part, you realize it is the same as the question. What was the question? What is the integral of x? Exponential ex, right? So this was our question. So the integral of x exponential ex will be this here. So when you evaluate this part, you will get the answer to this integral. So our next step is to evaluate this part here. So let us clear this one out. So let's evaluate this part. We have x, exponential x, minus the integral of ex dx, right? So that is going to be x, exponential x, minus, what is the integral of exponential x with respect to dx? It is still exponential x plus c. Remember to add the addition of c, because we are integrating an integral with no limits. Whenever you integrate an integral with no limits, you must add the addition of c. And whenever you are integrating an integral with no limits, you will leave out the addition of c. Now, this is our answer, but let us write it in a proper way. When you look at this answer, this exponential x is common in both. So you can write exponential x, x minus 1 plus c. So this is our final answer. Let us do another example. We can erase this part, right? So we can also erase this. So example 2, what is the exponential of x squared ln x dx? So the first thing is to choose your u, right? And your dv. Now to choose your u and your dv, you must use the mnemonic Liate, right? So Liate helps you to choose your u. So looking at Liate, L stands for logarithmic function here, which takes the first priority. I stands for the inverse trigonometric function, which takes the second priority. A stands for an algebraic function, which takes the third priority. T stands for trigonometric function, which takes the fourth priority. And T stands for trigonometric function, and E stands for exponential function, which takes the fifth or the last priority. So in this integral we are given here, we have x squared, an algebraic function, and we have ln x, a logarithmic function. So which one will be our u? looking at Liate, logarithmic function has a higher priority than an algebraic function, right? So our u is going to be ln x because it has a higher priority than an algebraic function, which is at the third priority. Now, the remaining part is x squared dx. So, after finding your u and your dv, the next part is to find the derivative here and find the integral here. So, let us first differentiate this. That will be u dx is equals to, we are differentiating u with respect to x. So what is the derivative of ln x? The derivative of ln x is 1 over x. So the next thing is to make du the subject now, not dx. In u substitution it is dx you make the subject, but in integration by parts it is du you make the subject. So here we have 1 over x, take dx the other side. So this is our du. Now, the next part is to find the integral of this part here. So let's find the integral. The integral of dv and the integral of x squared dx. Now, this is an integral and you are finding the integral of a derivative. An integral and a derivative cancels out to remain with v. So what is the integral here? It is going to be x squared plus 1 over 2 plus 1. Remember, when you are finding the integral, you add 1 to the power and divide the result. So our v is going to be x cubic over 3. So we have found our v and we have our du. The next step is now to substitute everything in your general formula. So let's find some space here. So what's our formula? Our general formula is u dv is equals to uv that is minus the integral of v du, right? So that is the integral of, what was our u? Our u was ln x dot, what was our dv? Our dv was x squared is equals to u, what was our u? Ln x dot, what was our v? This is our v, x cubic over 3 minus the integral of here v x cubic over 3 du. What was our du? X dx. Okay. So when you look at this, you can arrange it properly. The integral of x squared ln x is equals to, we can also arrange this properly, x over 3 ln x minus the integral of x cubic over 3 dot, now dot 1 over x dx. Now here you realize that what this was the question. This was the question. Our question was to find the integral of this, right? So the integral of this is going to be this here. So we are just going to work out this, and this will be the answer to this integral. So let us work out this. This is x cubic over 3 ln x minus, whenever you have constants in the integral, you push them outside the integral sign. So here we have these 3 here, with that is the same as a third. right? A third, the integral of this x here will cancel out with this x cubic, will remain with the x squared dx. So that is x cubic over 3 ln x minus a third. What is the integral of this? The integral of that is x cubic over 3, right? So we cannot write this answer properly. Let's just erase this one here. So we can write this answer properly. Let's just erase this one here. Sorry. This is going to be x cubic over 3 ln x minus x cubic over 9, right, plus c. So this is the answer. So 3 times 3, a third times this is x cubic over 9. A third is a constant. A constant times a constant is another constant. So this is the answer. So negative a third times this is going to be negative x cubic over 9. Negative a third times positive c is going to be another constant, which is c. Negative that constant, which is represented as c. So this is our answer. We can do one more example. And let me just erase this one out. I think now we can erase this. Leave that undisturbed. Sorry for that. Okay, let's do another example. Example 3. What is the integral of x tan x inverse dx, or others call it arctan? So let us choose our u and our dv. So to choose our u, we use the mnemonic Liate, right? So logarithmic function, we don't have it here. Inverse of trigonometric function, we have it here. This one, arctan. So our u is going to be arctan, or if you like, you can call it tan x inverse, because inverse takes a higher priority than an algebraic function, which is x. So the remaining part is x dx. Okay. The next thing is to find the derivative of this and the integral of this. So the derivative of u with respect to x is going to be 1 over 1 plus x squared. So the derivative of arctan is this. Wondering how I got this? So the derivative of arctan is a standard derivative that is found in the derivative and the integral mathematical tables. So when you look at the mathematical table, it does provide the integral and derivatives of arctan. So from the integral and derivative tables, the derivative of arctan is this. So the next thing is to make du the subject. Take dx the other side. That is 1 plus x squared dx. So the next thing after finding du is now to integrate this. Integrate dv, integrate the other side also. So this, the integral of this is v, an integral of a derivative. The integral, the derivative will cancel out, we remain with v. So the integral of x with respect to dx is x squared over 2. So after finding dv and dx, now we can use our general formula, which is the integral of udv minus the integral of v du. So that is the integral of, what is our u? Our u is arctan. What is our dv? Our dv is x dx is equals to, what is our u? Arctan. What is our v? This is our v. This is our v. Dot x squared over 2 minus the integral of v x squared over 2 du. So where is our du? So our du was 1 over 1 plus x squared dx. We can erase this one out. Even this one, we can just erase it out. Even this one. So let's arrange this properly. So that is the integral of x arctan dx is equals to, this is x squared over 2, the tan x inverse, minus the integral of x squared over 2, 1 plus x squared dx. Now here you realize this was the question, right? To find the integral of x, arctan x dx. So this is going to be our answer. So we have some part of the answer, this one. So the next step is to find the integral of this. So when we find the integral of this, we can substitute it back in this expression. So the integral of this one here, now you realize x, so we have a constant in this integral, this 2 here, which is the same as a half. And wherever we have constants, remember this is a product here. This is not a positive or a negative. This is a product. So whenever you have a constant, you can push it outside, right? So it's going to be half the integral of x squared over 1 plus x squared dx. So that is going to be half the integral of, now you realize x squared over 1 plus x squared can also be written as this, 1 plus x squared dx. If you break down this decomposition, you will find out this. But I'll provide a tutorial on decomposition of fractions. So anyway, let's go on. We can erase this part. So let's go on. That was a half. So what is the integral of this? The integral of 1 is x, right? Because this is this 1 is the same as x raised to power 0, right? So when you find the integral of this is the same as x, 0 plus 1 over 0 plus 1, which is the same as x raised to 1, which is the same as x. So this is x. So minus, what is the integral of this? Now you realize when 1 over 1 plus x squared, its integral is going to be tan minus 1x. You realize that our u was arctan x, right? So when we found the derivative of arctan x, it was this. it was 1 over 1 plus x squared. So when you find the integral of this, it gives you back arctan x. Remember to add plus c. We can erase this one out. So our answer is going to be this part here. So our answer is going to be this part here, x squared over 2 arctan x, right, minus this here. So this expression here is this after finding that. So that is a half x minus arctan x plus c. So we can write this properly. Let me just erase this one here. So that is going to be our final answer, x squared over 2 arctan x minus, so what is negative 2, negative half times x, that is x over 2 minus, what is negative half times arctan, and negative times a negative, negative times a negative is positive, half is positive half tan inverse x plus negative half is just a constant, just the same as 3 or 5. So negative half times positive c is going to be negative a certain constant, right? So that a constant, we'll call it C1. So this is going to be your final answer.